User stream. I haven't get yet. Okay. And that there is
has the most impact. So your people are more important than your processes.
Yeah, I have some problems here.
Are more important than your tools, right? So if you want to use Circle CI or GitLab Actions or GitLab CI or whatever, that's not as important as I want to automate my build process, right? And automating your build process is not as important as people saying like, yeah, I actually want to automate my build process. Because if they don't want that, then what are you doing, right? They won't use it, or they'll complain when they use it, they'll stop it. You need to think about these things, right? So this is the order in which you should see the priorities when you're thinking about doing something or taking a decision. Well, automation, the only point that I want to mention about it, because everybody is basically doing that for a living here, or most know actually what it looks like, is that you should automate the repetitive tasks that you have. Not any task for the sake of this is best practice, or I feel like doing it, or it's an interesting tool. Because if you do automate tasks that you don't have, you're doing nothing. You're just spinning in circles and wasting time and money and energy. So that's something that you don't want to do. And that's a mistake that people get pressured into, that people don't notice that they're doing. That's a mistake that I've done a lot for many years. So it's not something that's to be taken lightly. It happens a lot. Lean, iterate in small steps. So as Sebastian was mentioning earlier, like if you just hire a machine learning engineer and you tell him like, hey, I have this data, please give me a model, and then you let him go and you let that person do like 6 months, a year. Well, you don't know if you're... The conversation makes it sound like this is going in the right direction, then you iterate and you keep going like this, right? So you're reducing the risk of taking a bad decision, and you can short-circuit wrong decisions before they actually cost you a lot. Measurement, this is actually not that complicated. If you are having some kind of process, or if your people are doing certain kinds of things, and you don't see anything about what they're doing, you don't even see if there's a problem. You don't know if something is going wrong. You don't know if something is going right. You don't know to tell them like, oh, this is good. We should reward those people. You know. So it's basically like just look at what you're doing. It sounds simple in theory. The implementation is complicated, but the principle is there, right? And sharing. The most typical example where that does not happen is when people try to. Okay, let's say just an example, not the most typical one, but an example would be someone seeing that they have something powerful in their hands. Oh, I can do machine learning now. Oh, I can do this crazy algorithm. Oh, people have hired me because they want to see this and that. Let's make myself important. I'm the bottleneck for this thing. I'm not going to document anything. I'm going to do my Git repo with only one branch. Nobody can collaborate with me. And then, yeah, now they're stuck with you, right? And if you leave, well, they're stuck with nobody now. So, of course, if you start sharing, that means that you're more of a redundancy. So then you might think like, oh, now I'm at risk of being useless, so then they get rid of me. But what actually happens when you do this well is that people see, oh, this person is a team player. Let's keep them and make them work with other people and use them for more projects. And, you know, the cycle goes on. So that makes you actually more productive and less stressed, right? So this is the basic idea, right? And now agility. So just the objective itself as a reminder. So it's not speed, it's the ability to change direction while being fast, basically, right? And if I would apply that to the business context, the body becomes the company's product, strategy, and position in the market, right? So when we speak about agility, what we mean is, oh, if the market decides, yeah, your product that you've been selling for 20 years, now there's this new thing on the block, we don't want this anymore. Okay, what do, right? If all your processes are super rigid and locked onto your current business strategy, it's going to be hard to switch, right? And there's a lot of big behemoths that die because of this, right? Because they don't have enough flexibility in the processes to actually change the direction of the company, to modify a product, or to venture into a new business. change their business model, this kind of stuff. But even at the smaller scale, if you're trying to develop a product in a small startup with 4 or 5 people, but you're doing monthly long sprints, yeah, you get the customer feedback 3 weeks in. Oh, actually, this feature is not necessary. Let's do this other one. Well, you just wasted 3 weeks, right? Whereas if you do weekly sprints, well, maybe you just wasted 1 week instead, right? So this is what you want basically when you're thinking of DevOps. Yeah, like the reason why we moved from on-premise servers and Jenkins and Ansible and all these things that we had to do manually before, and having your Linux computers that you have to maintain yourselves, to, let's just write a few lines of Terraform code and Terraform apply, and then poof, we have a computer now. Right? Why do we do this? Well, it's because it's faster to change the decision, right? Oh, you want a computer? Okay, let's pay by the minute, and here's a computer. And okay, I don't want a computer anymore, bang, it's out. Instead of hiring a sysadmin, buying the machine comes in a few weeks, and then, oh, I don't want a computer anymore, well, okay, now I have to fire someone. Like, you see that the processes become much more heavy in terms of time and money and energy. So this is basically why we migrated to this, right? And so what I've been trying to say is that business agility is really the true objective behind the philosophy. It has a lot of positive side effects, but if it wasn't for this, businesses would not have adopted DevOps. That's basically where it comes from, at least in my opinion. You're welcome to disagree. So basically, when you have a better work culture, the problems get predicted and solved quicker when you work as a team, right? If someone figures out something but doesn't say it to anybody else, or doesn't want to communicate to anybody else, then maybe the information doesn't go into the hands of the person that realized that there's a problem, right? So this is one of the consequences. Automation. Imagine that you have a sequence of steps, let's say 10 steps, right? And they're all automated. And now all of a sudden, something changes in the business, you want to change one of those steps. Where if these things are all programmed and well decoupled, then you just go at that step, you change what you need to change, and that's it. Whereas if half of those steps are manual and the other half needs to be done with a meeting, then changing that thing means you have to set up a meeting to decide on the new process, and then assign the job of reorganizing this thing to other people, and it becomes slow and painful, and nobody wants to do it, and sometimes it never gets done, right? So lean, I've already mentioned a little bit about it. Measurement as well. I don't want to repeat myself, it's just everything's already there. And yeah, sharing, like imagine that the business is changing direction and 3 teams need to change one of their processes, right? If the business only communicates to one team and the one team is not aware that the other 2 need to change something, well, now you have like a lag between the previous process and the new process, right? So you have 3 teams, one team is ahead and the other 2 are like a version behind. And then you get kinds of problems that you wouldn't even be able to imagine sometimes. So going back to our original Google search, right? Basically now, because we understand what DevOps actually means, what is MLOps becomes the DevOps philosophy, meaning columns, right? Applied to machine learning software processes. Okay, so I'm going to go on and dive into details of what that actually means a bit more concretely. But first of all, are there any questions so far? Okay, let's just keep going. So the first one, culture. So let's say you're building a new company, right? Let's say it's an AI startup, and you have this idea that with machine learning, you're going to break into this new market, and that's the idea of the CEO. Start hiring a machine learning engineer or an MLOps engineer, and then that's you, right? And then you come to you and say, okay, what's the plan? I want this. And you say, okay, I'll be done in 6 months. If that's what you say, they have no idea what to do with you, right? They close their eyes and they wait. So if you need something from them, well, it comes as a surprise, right? So it's much better to think, okay, this person came to me with this problem and they think the solution is a machine learning algorithm. Let's have a conversation with them. Okay, you want this machine learning to do this. If you vulgarize what's actually happening behind the scenes, maybe the idea that they preconceived in their head is not at all what you're thinking of doing, right? So having this discussion to clarify what's actually going to happen and what are the implications for them makes your life much more easier. To give you an idea, I tried to build a chatbot company for 15 months, and after 15 months, my first customer asked me to build 3 chatbots that required no machine learning at all. And the statement that he gave me for saying why he wants those chatbots was, I want to understand if our company can develop in the space of machine learning. So you can imagine the frustration, spending a year and then realizing that you're talking to someone who doesn't know what you're doing, right? You can save yourself a lot of time, money, and pain by just doing this one point. Making sure that your colleagues, team members, and stakeholders actually understand what's at stake. Focus on the company objectives when building models, not on the models themselves. What does that mean? It means if you have a problem that you're trying to solve by defining some algorithm, the algorithm itself is not the end goal. It's just a solution to the problem. So make sure that you understand the problem really well from basically all possible perspectives. From the point of view of your company, from the point of view of the user that's going to use the model, from the point of view of the people that have to be involved, right? So let's say your model requires some company data to be annotated before it starts the training process. Well, these might be internal people, these might be external people. Maybe you're using something like Mechanical Turk or something like that from Amazon. Or there are services these days, depending on the data that you're processing, that annotate the data for you. You need to understand all these topics to see what kind of problems are going to arise and what kind of solution you at least plan to develop when the time comes. Because if you just do that, maybe the company decides like, oh, okay, this is actually too expensive, or this will take too long. So let's switch completely the strategy. And then you just save yourself a lot of pain, right? But let's say that works, right? Let's say the company is on board. Then it's much easier to outline the timeline and to keep the stakeholders up to date on what's happening. And the whole strategy of the company now gets aligned with that. They're on board, they understand what's happening, they know what to expect, they know what to do with their own timelines, right? And that's much more productive than just going blind for 6 months and then showing us like, hey, I have something for you guys to do, right? This happens a lot. It's not just a funny statement. Yeah, and this goes a little bit into the third point. Like, you want to orchestrate the people, the processes, and technology to deliver trusted, high-quality data for training your models quickly, right? So, depending on where your data comes from, it needs to be annotated. If there's some governance issues, like maybe you need to be GDPR compliant to process that data, so you need to anonymize some things on top, you need to aggregate some data. These things should not be done by you, ideally, or should not be done by the machine learning engineers in your team if you're just responsible for the MLOps part. Because in small teams, oftentimes the people doing the deployment of production and the engineers may be the same people. They're just roles, right? They can be assigned to the same person. So it's really important to get that figured out, at least at a high level, before you think of writing down an algorithm, right? Okay, automation. So this is the part that is easy to get wrong, and what usually happens when a model doesn't go to production is that one or more of these steps are basically not known or ignored, right? And then you realize that you need too much time to go to production. When you're in production, you have too many problems, and so the model deteriorates over time. And so these are the few, let's say, tips that I have so far. You want to facilitate the deployment, right? So let's say you've worked on Google Colab or AWS SageMaker or any kind of trained as a service provider, let's say, and then you have your model, right? So how do you make sure that that model goes on a server where it can actually be reached by the other services that the company is using, right? So you want to automate that part, right? To make sure that this process, every time the model gets retrained, doesn't need to be redone manually, which happens a lot. Infrastructure as code, CI/CD pipelines, this is where the typical stuff that DevOps engineers would do, right? That's where it happens. Going on a little bit after that, so make sure that like your machine learning model, when it's sitting behind the server, if ETLs need to be connected to it to feed the data from its source for live predictions, let's say, or if the data needs to be cached before the users actually use the predictions. A good example would be a search engine. So you could think of an example of a model I worked on, for instance, was that we had data from our providers of the product, and then we would run the machine learning model on that data, and that data would be stored in a database, and the user would just use that data like an index for speeding up searches and getting recommendations. So that means that there needed to be some process that when we deployed a new version of the model, that would automatically go through the data that we had and then create that index, right? This is not something that you just deploy the model and then, okay, it's accessible, so the process is going to run. No, there's like processes around the fact that you have a new model that need to be run, and these need to be orchestrated, right? So this is kind of these are like two specific points, and this is kind of a general point. You want to reduce the friction in the model's lifecycle. So you need to train the model, you need to deploy the model, you need to use new versions of the model to run it on maybe live data or data that is available at the moment of deployment. And all these things, if they're done manually, they take time, they might be skipped because of deadlines. And depending on the business model, the things that create more friction might be very different, right? So like for instance, if you're running on live data versus if you're predicting on live data versus predicting on data ahead of time, your process is going to be completely different, right? And so also depending on the team, depending on what they're good at, depending on what they've already automated, maybe, when you show up, it's pretty simple. You just go ask them like, look, what's costing you a lot of time? What are you not doing because you think it's too long? And then you try to reduce these things first, right? Instead of automating what you think is the best practice, start with the ones that actually cause pain, right? Second slide for it, because I have a lot to say. So your model, when you train it, typically what's going to happen, let's say it's not like a simple linear regression, but something a bit more complicated, maybe a deep neural net. You're going to have a data set, and then this data set is going to be pre-processed and then used for training. And then maybe in the training process, there's like random seed generators, you have a train test split, you have a bunch of things that are random. So you want to, maybe some hyperparameters as well. So all these things can be saved as configuration to be able to repeat the experiment. And there's many reasons why you want to be able to repeat it. First of all, just to confirm that you didn't get lucky, right? Your algorithm is not working because, oh, it works on my machine, you know, that kind of stuff. But also, let's pretend that in production, there's a bug, and one potential source of the bug is the model, right? So if you cannot repeat the experiment, maybe you just retrain, and then you realize, oh, okay, the problem is gone. Maybe it was the model, maybe it wasn't. Especially when you're dealing with statistical engines, maybe you just got lucky. So it's important to actually know what happened, and making things reproducible enable you to basically debug, right? You want to automate the data flow required to create data for training and testing. So what that means is, let's say the data is sitting on Google Analytics, right? You want to train the customer data. And then there's a whole process. You need to query it, you need to anonymize it, you need to aggregate it, and then you need to do the train test split. So if this is always done manually, and you need to retrain, I don't know, if your model is not that complicated or complex, let's say, maybe you need to retrain 20 times a week, right, during the research process to figure out what's the best model. Well, automating it the first time sounds like something you want to do, right? Saving yourself the time of doing something you do 20 times, it pays off quite well. And then there's the other side of it, right? Your model's been built, you're deploying it, but then the rest of your company actually wants to use that model. Maybe you use it for business intelligence, for data science experiments, maybe they use it for analytics, maybe they use it for the actual product. There's plenty of use cases for that, and you don't want to communicate with those teams and tell them like, hey, by the way, can you go and do this task for me, because now the new model is live. It's much simpler if you just automate that, and then you tell them like, look, you received an update, send them maybe an alert, and then they know what to do with that, right? So, I just want to add, like, of course these sound like things that might be very time-consuming to do. But think of the points that I'm making here not as a, if you don't do this, you're not doing MLOps, but more like, these are like points to go in the direction of understanding the philosophy better and applying it more and more gradually in your company, right? If I would say tomorrow you apply all those points, that wouldn't be very lean, right? Iterating in small steps, that's kind of the idea of the whole thing. So maybe you start with the one that is most painful, and then you move on and find the ones that apply most to you. So speaking of lean, yeah, so you look at the life cycle of the model, and depending on your business, the algorithm you're trying to define, the data that you have, there might be certain points in that process that are more or less time consuming, right? So if you break down those steps, and you can use like a, I mean, I imagine that most of you are aware of like diagram software like Draw.io or something like that. You can break down the process and then basically assign, okay, this part is done by, let's say, this script or this third-party application or this person in the team, right? And then you break down these steps and then you realize that, okay, this is super time consuming, this not that much, this is fine for now, it could be better, but this is taking me 1 hour a day, this is taking me 3 weeks, right? So let's start with the bigger one. And then the other thing to realize is like, let's say you're trying to define the product and you see like, oh, we could use machine learning for this, we could use machine learning for that, and this, and that, and that. Machine learning should be thought as an expensive solution, right? It takes a lot of time, it takes a lot of money, it takes a lot of energy. I mean, unless you're trying to just build a simple linear regression, in which case it's as expensive as basically rule-based algorithm these days. Thinking more like the deep learning, computer vision kind of approach, right? This is not something that you just sprinkle on all your problems, right? You need to carefully invest this. And if some of these problems in your product definition could be solved by simpler problems at the beginning, then basically like solving them with these simpler approaches and then investing in making the product more complex to better accommodate, let's say, the end user of the software is a much more linear way of doing things. So to give you an example, let's say you're looking for your first customer, right? And you're thinking like this AI product is going to be the new hot product on the market. If you start by solving all the problems of your one customer, and they're not paying yet, well, maybe slow down a bit, right? Maybe think, okay, talk to your customer and say, what's your most painful problems you have right now, right? And then it's, okay, this part, let's sign a contract for this, or let's have a POC for this, right? And then you have a little bit of budget, you have something you can focus on, and then when this works, you go back to your customer, they're happy, they want more, and then you iterate, right? So, okay, next point. Okay, let's say you're working with a much bigger customer, right? We're not talking startups anymore. Maybe like autonomous driving, something like that, where you already know, like, okay, you're dealing with terabytes, petabytes, or something bytes, much bigger, and then you want to train them all on that, right? If your training process takes 2, 3, 4 weeks, what most of you probably already know about, like, let's say Spark, right? To be able to parallelize processes. Instead of training on the same set of GPUs for multiple weeks, you can think, okay, maybe I can train multiple models on multiple machines and have my data center completely distributed. And then you can parallelize these things and then shorten the life cycle by a lot, right? I gave the example of training, but of course this can be done with like, multiple methods. Yeah, do not reinvent the wheel, right? One mistake that I've seen done by other people, including and myself, is that I was thinking like, oh, this problem looks really complicated. Let's invent this new crazy algorithm because with my new crazy algorithm I could solve the problem. Yeah. Usually by a bit of research, you find something on AutoML or Keras or I don't know what, and you can just dot fit, put your data in there, and then you get a result today, right? This might be tempting to do, and might make you feel like you maybe have some power, or that you're now more important to the company because you managed to do this, and nobody can do this because you're the first one to do it ever. That doesn't last. Yeah, that feeling it doesn't last forever. Whereas the feeling of actually providing value to the company, if you keep doing this over and over, that will definitely last. So, measurement. Right. So you're developing your model, and then you have your dashboard that tells you about maybe the mean error of your model, and then the variance of the error, and then you have an idea of how accurate you are, precise you are, you have all your metrics, precision, recall, all this stuff, right? But the business doesn't even know what that means. Like you talk to them and say, yeah, okay, I have a low F score. They might have, okay, what about the G score or the H score? Yeah, they don't know what they're saying. So you need to basically figure out like what matters for the rest of the business. Because you know what matters, right? You can think like, I have my statistics and so on, but what the business actually cares about to determine if they actually want to use this, well, they want to know like, okay, I had these 50 people in my company that had to annotate the data. Are the predictions on that annotated data actually decent, right? Or do I have a 20% error rate? And I have to deal with a huge error rate that I don't know what to do with. You want to know the model performance on live data, because maybe you did your train test split, yeah, and then on your training data and test data you performed super well, you go to production, and then there's some bug, the data comes in wrong, and then predictions were horrible, right? Maybe there's nothing wrong with your model, but if the output of your model is wrong, then you want to know. If you don't know, then you're in big trouble. Data drift. So this can happen, for instance, if you have ML solution that applies on a seasonal context. So I mentioned earlier I was CTO in a fashion startup. Basically, one of the models that I built was about extracting features out of product images. So people like would have an image of someone who wore clothes, or earrings, or shoes, and then the model would extract features out of that. But the clothes in the summer are not the same as the ones in the winter. So if I train a model on summer data, and then I apply it on winter products, the results don't even make sense, right? So you need to be able to measure, like, at what point is your model actually underperforming compared to what you've seen when you were training it, right? Or just basic errors thrown during processing. So let's say you assumed your image processing model was going to expect like an image of this format, and then suddenly something like this gets thrown in, and then all the matrices in the deep learning model go like, oh, the dimension errors, you don't know what's happening, right? So you want to see this in production, because maybe it has nothing to do with your model. Maybe it's just because you expected that, and then you wrote an ETL expecting that, and then the user decided like, oh, okay, you said to put this image format in there, but I'm going to give you something else, right? If this happens once, you might say, let's just talk to that person. But if it happens 50% of the time, maybe there's something wrong with the product, right? Maybe it wasn't explained properly or designed properly, or maybe we just need to make a model that actually fits that use case, right? So measuring these things basically raises the right questions that you wouldn't otherwise not have and not know what to do. And so how do you figure out those questions, right? Because maybe, like, I'm the best example. You don't see me as a fashionista, yet I was working in a fashion company. So I had to ask a lot of questions, right? They were coming up with these features that they wanted me to extract. I had no idea what they meant, but I had some numbers to crunch, so I was like, okay, let's do it, right? And by talking to the different teams, I could actually figure out what they want, right? So if they want to know what products. So, to give you the context, like the model was used as a recommendation engine. So basically, imagine that you like a pair of shoes. So you buy a pair of shoes. It goes with your suit. It's very fancy, very formal, right? And then the next day you come and you want a tie, right? Or you want a shirt. Well, the shirt that you're going to buy after buying shoes is not going to be the same shirt after you buy a bikini or something, right? So we wanted to make sure that these kinds of products sort of came on top. And then they actually didn't want to know, let's say, the top 50 products that came on top. They wanted to know the top 3. Why? Because they're the ones that show up on the page when you open the website. So if I hadn't asked, I would have just given them statistics like, oh yeah, on average, the first 50 products, they look okay. And then they would try the product and be like, no, right? So these are the kinds of questions that, like, you don't have the answer, right? The answer doesn't come from you. It comes from domain knowledge, or it comes from teams that do something specific with data that you're handling, right? And the only way to really figure out what you actually have to measure is by asking. And then finally sharing. So, okay, so you've asked your teammates, you've asked your colleagues, you've asked the CEO or management, okay, these are the measurements that you want. And you actually produce those measurements, but then they need to have access. Because if you're the one sending emails every day, you're not gonna like your job here, right? So you wanna make sure different teams have access to the data surrounding the model to act accordingly and know what to do with it. So if you need data annotation on the data that you're receiving, do the annotators actually know what to do with it? Are they using the labels that you want them to use? Or are they saving the labels properly? Maybe they're saving them in the wrong format. Let's say the label is a date. We all know that dates can be super painful, right? So, yeah, document as much as possible. I mean, we keep saying it, documentation is important. But the documentation, you should see it as something that is not just for others. It can also be about yourself, right? So let's say you haven't documented something that you've done manually because you're thinking like, nah, this is a one-time thing. And 1 week later, you have to do it again. Okay, I haven't documented it this time, but it's a one-time thing, it's fine. 2-time thing, okay, so you do it again manually. And then 3rd time, okay, now I've been doing this 3 times, but I don't have the time to automate it because I don't know how to do this. But you don't document. Which means that every time you have to do it again, you spend 10 minutes doing it, and an hour figuring out how to do it, right? So, not only if you do this, you become more productive because you actually have a way to remember and save yourself all the research, but you can ask someone else to do it, right? And then you become less of a bottleneck and a bit more redundant. And yeah, let's say you do a change to your model, and it has some impact in other departments or in other teams, or even within your own team. Right? You want to make sure that these teams are updated. So typical things that you can do is just set up an alarm system. Hey, there's a new update. Or maybe the alarm is not on the model update itself, but maybe the model processed some data, and then you want to let know the relevant people, hey, the data has now been processed, it's different. So maybe you should check it out. Maybe you need to do some verification on the processed data. So all these kinds of things, right? So I mentioned data quite a few times. What about the data people? And by data people, I don't mean like annotators or people like users. I mean data scientists, data analysts, the people that actually work with you on building this whole setup, right? We're focusing mostly on machine learning here. So basically, we have this narrow picture that was about, okay, we have to build this machine that takes data in, processes it, and then spits data out. And then we need to know, okay, these people need to know how to put it in, and these people need to know how it's coming out, right? But like data is not just about you, right? It's not just your machine learning model. It comes in all kinds of different ways. It's used for all different kinds of purposes. It has all kinds of restrictions on it, legal or just internal, you know, all kinds of stuff, right? So imagine that MLOps is that little circle. There is this big world of data ops that's surrounding it. And maybe this little part right there is just about you and your machine learning model, but that's the part that overlaps with what's happening with the data around it, right? And this is basically what you're looking at. I will just slowly go through it, so don't try to like speed to it. I guess I have maybe 5 minutes. 2? Okay. So what do you start when you think of a data-driven company, right? I mean, that's usually how machine learning companies tend to label themselves. Oh, we have machine learning, so we're data-driven, right? But what's behind it? So first of all, you need to have a strategy. Where is data coming from? How expensive it is? How much work do you have to do with it? Do you have to annotate it? Do you have to modify it? Do we have to protect it? Meaning, like, in terms of security, because it might be stolen easily, or is it publicly accessible? All these kinds of questions, right? And then if there's governance problems, who owns the data? Who has the right to do this and that with the data? Is it problematic with GDPR? Do we have to process it to make sure that the people that have access to it in the legally correct way, right? Once it's taken care of, setting up infrastructure, meaning like this is the part where you do engineering in the cloud, right? Setting up a data lake maybe, that might mean like, okay, you have data coming from Google Analytics, SAP, your users, sorry, data produced internally by some algorithms, or even your people. All these things need to be orchestrated, and the role of the data ops process is basically to ask the right questions and define those things. And the data ops consultant will show up and basically ask those questions and give the typical answers or the usual solutions to solve these problems and the usual questions to come up with these problems, right? And then when we show up here, this is basically the part done by usually by data engineers. So you want to set up ETLs, you want to clean that data in the way that your company needs it. You want to have some quality assurance to make sure that it's actually been done properly. You want to monitor what's happening, and then maybe there's some parallelization necessary or some batching. And then once that's done, then you end up with APIs and visualization that can be used by the company and its users, right? And at that step, just right here, like what's happening in those areas could have been done by some model, which could be a machine learning model. And that's where MLOps is sitting in that little, like it could be like one slice of multiple slices of that part of the process. So what I'm trying to say here is that MLOps is actually a little part of this bigger operational nightmare, if you do it wrong, of data ops. And in my personal experience, that's actually one of the main reasons why so many problems have been dealt with the wrong way. I even remember my first month doing machine learning, I received a SQL query of 4 million data rows, and it was called the Data Millionaire, right? So it gives you an idea, like if you don't ask all these questions, you're basically running into a million problems, not knowing what's ahead of you, right? So I hope I gave you an idea of what is surrounding the operational aspects of machine learning, and I just want to finish with a quick quote from one of our ex-colleagues at Polo Squad. This is about business. This is not about technical stuff, right? So in business, the tech is easy, people are hard. So if you just want an AI model, right? If you want a machine learning model doing some predictions, you hire a machine learning engineer, give him a laptop, give him 6 months, poof, you have a model, right? But then, if you want that model to actually do something, be used by people, be managed by people, be designed by people, be maintained by people. If you want this thing to be deployed, be used, be scalable, be maintainable, this is hard because there's a lot of people involved, there's a lot of users involved, there's a lot of management involved, money, right? All these things are hard to coordinate. And this is where these disciplines that I mentioned, like basically the data ops process and the smaller process of MLOps, this is where doing things the right way actually pays off. It's not at the technical level, it's at the organizational level. Okay. So, thank you.
Hey, any questions? How about you?
How do you remove the biases of different people when you're asking to ask me the questions? Remember the 3 pictures example you gave? People will always come with the person bias.
So sorry, what picture you're referring to? Because you mentioned 3 pictures.
So we gave the example that the model was about 50 pictures.
Ah, right. I mean, so, sorry. It's not a simple question to answer, but I would say, like, if you want to be on the safe side, like, first of all, ask multiple people. That's something that I did lots. Like, I was asking one person, and I wasn't, like, taking that for granted. Because sometimes oftentimes they interpret the question in their own way, and then you think you got an answer, and then you ask someone else, and you realize, like, oh no, actually that's what this first person meant by asking the second person, and then you ask the third person, and it's like, oh no, that's what the other 2 meant, right? And then you talk to them again, and you ask the same question, it's like, yeah, that's what I was trying to say, right? So the company was Italian, so you can imagine like how they just like to ramble and say things, and they think they're clear, and they don't mean bad, but it's just that if you come to them with a completely new perspective, and then you ask new kinds of questions, of course the answers are not going to be like as coherent as you might imagine. But yeah, I would say like it's mostly about, I learned about trial and error. I have a lot to learn still, of course. But I would say if you get the feeling that you still have some insecurity, just try asking it in different ways to different people. Try to make sure that everybody is seeing the same picture. That helps a lot. And vulgarize as much as possible. Yeah.
Hi, also from Aloha. Considering that Polarsquad is a DevOps company,
Yes.
how many MLOps cases do you see?
Cases, not that much. That's kind of why this last slide was so important for me, because it's a very small subset of the whole DevOps idea, right? If you think of data ops as already this bigger picture, it's still a subset of the whole DevOps, which affects the entire company from this perspective, right? And so we're actually less than 5 people, I believe, in the company that can actually deal with the data ops. And usually when we get a data ops case, we're already very happy. But MLOps itself is like a very specialized area. It's very niche, right? So it's pretty rare to have to deal with them. And then when you actually have to deal with them, the question is, you actually have the experience to deal with the specific technical setting that's happening and can actually help in a reasonable time frame. So it's not easy, but I think we're all pretty excited if one case would come along in the next few weeks. I would be happy to jump in. Let's just stop here.
Yeah. Hey,
Yeah.
Oh, sorry. Yes.
From the online chat, there is one question that will the slides be available after the presentation?
Of course. No problem.
Excellent.
We can communicate and make it happen, but
Yeah.
I'm putting them out there for sure.
Cool.
Cool.
Excellent, thank you, Patrick. Hey, let's have a 3 minutes break. So you can grab food, you can actually visit the restaurant, and we will set up the next presentation with Emma. won't be too late. Next one is Emmanuel Ryan. He's giving a call on best practices.
Am I audible at the end? Good. I'm Emmanuel Raj. I'm working at Relex as lead machine learning engineer and team lead. We're building something called the AI platform, which heavily uses MLOps. So we'll take a look at MLOps from another perspective. It's good that we went through Patrick's presentation because it really laid down a nice foundation. So we'll look at some other perspectives to begin with, and then we'll look at some security and governance practices. So before we start, just a little bit about me. I try to do multiple things as well. Firstly, I work as lead ML engineer at Relex, and then also I try to look at machine learning from research perspective. So I'm also engaged with Arcana University as a researcher. So publishing research papers on machine learning, blockchain, NLP, computer vision, and different topics around these. And also I wrote a book called Engineering MLOps, which came out in year 2020, and it was best-selling book in AI category for some time last year. I think it's due to the fact that MLOps is growing and MLOps is able to solve many problems in the industry. It was, it was an experience to be an author. I never wrote a book. This one was the first. But today, with the presentation, we'll look at three things. First, we'll look at what MLOps is in simple terms. I'll try to demystify it, try to simplify it. Another perspective to add to what Patrick was explaining us, and then we'll look at some security aspects in the workflow, how to improve that, and also some governance practices that can help you to govern the system, to automate, optimize, and enable transparency within your organization. So before we jump into MLOps, I think it's easier if we talk the same language. So AI can have many definitions. So I just try to keep it simple with this equation. It sums it up with data plus machine learning plus human in the loop. Usual AI cases represent this. So there's data, without data there's no AI. And there's machine learning algorithms or even simple statistical algorithms to solve certain problems. So we fit the data to it, and then there's human in the loop to monitor the system, to teach the system, and to guide the system. So without humans, it's incomplete. So beginning from there, we look at MLOps, adding to the perspective which Patrick gave. So MLOps is a fusion of DevOps plus AI, and AI meaning the definition we saw earlier. And MLOps is trying to solve a problem that DevOps could not. That's why we have MLOps. So usually the way we develop model is we have data and we have the code, and then we churn out a model out of that after training process. So what happens in a usual case if we don't have MLOps or any process guiding the development practices in companies is we have data that increases over time in one direction, so it's exponentially growing. And in order to cope up with the data and to manage the data, we generate code which might not be linked, and they end up growing in different directions. So there's a technical debt to manage both these. So that's what MLOps does in terms of versioning the data and in terms of versioning the code as to see what model came out as a result of what code and what data. So MLOps is good at that to begin with, and it's the experimentation part where MLOps is useful compared to what DevOps could not do, and we have this perspective now that MLOps enables. So this is again a simplistic, try to simplify as much as possible, overview of MLOps workflow. It's coming out of my book as well, and it's a modular framework. So there's a build phase where we build the machine learning models. There's a deploy phase where we deploy the machine learning models, and then there's monitor phase where we monitor the machine learning models. So looking at it simplistically, the build phase, I think most of us might be familiar with this. First, we ingest the data to train the model. So here we do the ETLs and all the data engineering part to get the right data, and then we train the models using that data. We fit the models and it can be any machine learning models, statistical models, it can be reinforcement learning based, any kind of models, so this process can apply to that. And then we test the model based on a test data set to see if the model is performing good enough to progress from a POC to a solution. So that's what we do there in the model testing, and then once that passes, the model passes the test phase, we package the model in terms of serializing the model into artifact. So model, when we train a model, it lives as a variable in the code, right? So we need to transport that variable to somewhere else to make it work. So we serialize it, and guys might have worked with Pickle or Onyx, different serialization techniques. So that's what we do there, and then we package the model into a container usually, because these days we want to standardize the way we deploy the software, and scalability is an important thing. So many people in the industry are taking this approach of containerizing the applications. You might not go that route, but that's recommended. So that's what we do in the packaging phase, and then we register the model. And registering the model, this is where another good feature of MLOps kicks in. So in the MLOps stack, we have something called a model registry, where we register all the models that we train. So it's like a central repository of all the models. It's like GitHub of all the models that your team is working on. So you can always refer to a particular model and check what data was used, because all the data is versioned as we saw before, and what code was used to train that model. So we see all these in the registry. It's a nice way of representing all the models and even communicating with your colleagues. Otherwise, if you are working on each other's laptops, sending those on emails or sending those through GitHub isn't an effective way, because there's no lineage and things can get lost quite soon. So that's another advantage of model registry. And once we have our model on the model registry, we go to the deployment phase, where we package the model into an application. So that's where software engineering comes into play, where we take the model, which can be a container or a serialized file, we package it into an application. So some of you might have worked with Flask or Fast API, these kind of frameworks. Just to simplify, there are some other ways of doing it in Java and other programming languages as well. But that's how we build the application code to package the model. And then we test the model packaged into an application in a production-like environment. So that's the typical staging or acceptance environment in DevOps practices. So that's where all the testing is done in a production-like environment. And if we pass that test, then we go to the production release, where we do the production release and the model is in production. And once we do the production release, it's important to also monitor the model that is deployed. Without monitoring the model, we cannot really automate and understand what is happening with the use of model. Is it satisfying the business needs or not? Is it working as expected or not? All of this is important to understand, and that's where the monitoring component comes in. So we'll go a bit more into detail as to what that is. But in simple terms for now, we monitor all the logs that our system generates where we deploy the model. So meaning the input and output of the model. Then the system logs if there are any errors or exceptions in the system, some things like that, and then we analyze them. We can even automate this analyzing process. We'll get into it more. But then we govern the system based on these logs. We can automate and perform certain actions, but we'll come to it. This is in simple terms the MLOps process overview and how it differentiates from DevOps. And a bit more bird-eye view to add to what we just went through. That is the process overview. And then these are the 5 drivers that drive the whole process. So this is again part of my book. There's data, code, artifacts, middleware, infrastructure. These are different drivers in the MLOps process. So data, there's training data, test data, and at the end when we deploy the model, there's monitoring data. So that's the kind of data we're dealing with. And then for code, we have the training code where we train the model. Then we have the testing code where we test the model here. And then we have the application code where we package the model into an application. So when it comes to artifacts, we have the models, train model, package model, and the production model. And it can be other artifacts as well. It can be other data artifacts that are used as scalars for inputting data to your model, or it can be any other artifact that your model is dependent on. So it differs from case to case, but usually the models are artifacts, and we use middleware. This is turning out to be a standard in the industry. Many people are used to Git already for source code management and version control of the code. Then we have Docker to containerize applications, and we also have model registry, which is a central repository of all the models. Then it's getting quite popular to use Kubernetes to orchestrate the deployment of containers. And then we secure our deployments using VNets and other networking protocols that can be in place, having firewalls or your own custom rules to orchestrate your system. And then you can have also a feature pipeline connected to your feature store. And then infrastructure, it's usually quite popular to use cloud or on-prem, so it can come from both. So training compute is involved, production compute where your model is deployed, so make sure that it's big enough or auto-scalable to serve your needs. Otherwise, there's central storage where you save all your input data, output data, and everything related to logging and monitoring as well. So this is bird's eye view of the MLOps workflow. But then let's come to the other interesting part. But before we come there, I'll just pause for taking one or two questions. Then we can go ahead.
So in Relex, we have a lot of data in production, and it's a lot of data actually to run a model on it. So in your data model, I'm not seeing that the production data and the test data are different things. So you have to.
Good question. So where is the data coming from? So at Relex, we have huge amounts of data. So where is the data coming from and going to? So let's take a look at that. So for training the models, we ingest the data, and this is usually coming from our something called the data platform that we have. It's a central platform within the company that hosts all the data of our operations, and we ingest the needed data from there. And here in the production, of course, we don't have a link from here. But good question, good that we can clarify this. But usually data can come from data platform to the production endpoint, or it can come from external sources. So we can inject multiple sources of data into the AI or the ML endpoint. So that's the way data flows in to the endpoint. In production, that's the way data flows in to train the model. And at the end, data from production is saved into the central storage. So that's the way it works. Good question.
Do you have your own data platform on Relex or?
We do. Yeah.
Yeah, because I was just thinking that you mentioned in the beginning that for the model and the whole pipeline, you have to also store the data, kind of keep the version control and so on. So you are also having the version control stuff on the data platform.
We are now building data platforms, so there are so many actually roles opening up for data engineers. That's one thing, you guys are passionate data engineers, we're looking for you. But there's constant work going on, and I think this industry is quite evolving. MLOps plus data ops, as Patrick mentioned. So that's part of the data platform.
Is there any specific middleware that you're using for the model registry?
So right now we try to go cloud, and we use something from the cloud. Open source can be used as well, like there are MLflow or other tools. But the challenge with that for a company like Relex is we need to manage the technical debt that comes with it. So there's a lot of customization that goes in with open source software, and then managing it, orchestrating the pipelines and other tools for it. We went with the cloud route.
Thanks.
And something I can give you a bit more info, that we use Azure ML, like we are on Azure with the AI platform. So that's something that I can openly say. it's becoming a quite interesting service. Also quite useful to learn that.
Any specific reason why Azure?
It's just that as a company we've been there. I joined like 1 year ago. Since it was there, we went with that route because many systems are already integrated there.
Our retail customers are interested in something which is not AWS.
Okay.
Yeah, AWS is a threat for a lot of retail stores, right? So Microsoft. But yeah, maybe we can delve more into other topics and then we can take more questions. So we'll come to security, and typically what we are faced with when it comes to security is this kind of attacks. There can be more. This is just a generalized way of putting it. So when it comes to the setup, this is the training stage. That is the inference stage. So training stage is where all the model training happens. Inference stage is where models are deployed in production, and inference is basically you putting model in production, sending input data, the model predicting something and giving. That process is called inference. So let's start with the training stage. There are various attacks that are possible. So poisoning attack. This is where fake data or wrong data is injected into the training data set. So it can come via the backdoor attack. Again, the backdoor attack is where you might be having an intruder which might be coming in because the security is compromised or some access policies are compromised. So they took advantage of that, and then they have backdoor access, and then they're able to inject wrong data into the model. So that will give bad results in real life. So that's possible in 2 ways. And then transfer learning attack as well. So transfer learning is a process where you can learn from one model to another. So in that, the attacker is able to substitute one of the models with their interests and able to infiltrate the model transfer learning process. So the model learns wrong weights, so it at the end gives bad results. So that's also possible, and these kind of attacks are possible in the training state. So we'll come to what kind of security measures can help prevent that. But in the inference stage, there are other kinds of attacks. One of the most important attacks that's quite possible in the machine learning world is adversarial attack. So here again, the attacker is basically sending fake data in some cases to influence the model output and the model system, and also trying to reverse engineer the model itself by sending a lot of data and understanding the model built or patterns, and then reverse engineering the weights of the model and then having the model itself. That's how model extraction can be done in one way. And then data extraction again by having backdoors. And so these kind of attacks are possible. So it's important to watch for these kind of players. So we'll go through some measures. But
Have you seen actually those attacks happening in production in practice?
In that Relex?
Yeah.
Yeah, we've had instances where these kind of attacks were tried, but thankfully there wasn't any success. So we monitored for these kind of patterns, especially when it comes to adversarial attacks and monitoring our data.
Could you share like what specific what technique like adversarial attacks, or did they try to do?
I think adversarial attacks were attempted. Backdoor is not possible because we have strong network rules that don't let outsiders to easily communicate with our infrastructure, and then we have strong access policies, and then we also monitor all our data operations end to end. So we've locked in the backdoor attack part quite nicely, but then when the endpoints are exposed to the public, there are usually players who try to bombard the endpoints with fake data and play around. But we've done something that has saved us from this as well. So we are not exposing our endpoints to, we're trying to not expose as much endpoints as possible to public. We put them in our VNets and we give access to only delegated parties. that we know of. So that's one way to save from adversarial attacks. But internet is internet. We have all kind of people.
We label these programs as attacks and imagine that there's like a bad guy out there trying to do something to the good guys. But I'm thinking, for instance, like data poisoning, like this could happen by accident, right? Like if your model is like out there or you gather data from your customer or something, could be that there's some data in there that's just like not your business model at all. And, do you somehow take that into account when you do the data cleaning process? That it's like, oh, it's for my customers, so it's valid, but maybe it'll work anyway?
Yeah, it's a good point. It can happen internally as well. It can be a human error, or it can be unintentional, it can be intentional. There are different kind of things that can happen. But ultimately, it's the responsibility of the data scientist to ensure that poisoning doesn't happen.
Poor guys.
Yeah, poor guys. But in some cases, we can automate that process as well to detect some certain patterns in the data and to recognize if it doesn't match. So ultimately, those guys, data scientists. So before we delve into security, I wanted to give you a bit more of what goes beneath before we go to security. And this is hierarchy of needs for testing ML systems. And part of this hierarchy is it starts with testing how robust the systems are. And while we do that, we also test for scalability. And then we look for security. So that's the most important thing if we look at the hierarchy. So if you look at robustness, when we deploy our ML systems, we go with this approach of doing unit tests on each component we develop, each functions, to test the inputs and outputs if they are matching particular format or matching the desired results we need. So we define those cases and we take the unit test driven approach. After that, there's also important to test the data and model. So for testing data, we have some statistical models that are able to give us insight on data's integrity, is the data coherent, correspondent, these kind of approaches. And then when it comes to model, we also need to check if everything is good with the model in terms of input shapes that we define, and also like how we serialize the model, how we ensure that it properly functions in terms of robustness when we deploy. So these kind of testings are done. And then integration tests. These are also including the functional tests where multiple functions or multiple features in the product are integrated together and tested in groups. So let's say that there are two different systems. So that kind of testing can happen. Also in one single system, multiple features can be tested. So it depends case by case. So this is the kind of approach we take. And when it comes to scalability, we do the system tests to make sure that we have enough compute resources, enough memory and everything working with the auto-scaling part, these kind of features. And then we come to testing the endpoints or our models to serve our business needs. So we do A/B testing, canary testing, and shadow testing. A/B testing involves testing out two different solutions parallelly at one time with different traffic. And then canary testing involves sending majority of traffic to one endpoint and a small chunk of traffic to the other endpoint to test and evaluate which systems work at the end. It's a statistical way of testing at once. And shadow testing is a way where we test multiple endpoints at one time. So it can be 4, it can be 3. So then at the end we have statistics. So these are different approaches that we can take to test the scalability and in a way robustness as well of the system. And then we do load testing. So we bombard our ML systems with X number of inputs that they are needed to ensure that we can handle the traffic whenever there are high traffic times. So these kind of tests are done to prove that the system is scalable, and then we get to the security. So once all of this hierarchy is fulfilled, only then we release solutions for production. And we are improving a lot of ways in security. It's a constant work ongoing, but these three are aspects that we look into: privacy by design, encrypting our data, and then real-time monitoring of ML systems. So let's look into one by one. So usually it's recommended to do homomorphic encryption. So here is where data is encrypted using certain techniques into ciphertext. These data packets cannot be decrypted without private keys for the outside world. So we try to follow this principle. We are improving on this. There are still a few cases where we need to get good at this, but it ensures that data packets are secure when data is transported, that other parties cannot decrypt it without private keys. And then privacy by design. We try to implement this kind of approach when we design our ML systems and ML models in general. So part of this is the idea behind this philosophy is to approach embedding privacy, fairness, transparency into the development and design process. So some of the aspects that we do is we collect and process minimum amount of data as much needed, and then privacy into engineer's radar. So, and then having a strong identification and de-identification technique, and also having a strong hold of access policies, and also having end-to-end lineage, because our customers can any day ask us what is happening with our data and how is it being used. So we also believe in transparency, and we are responsible to provide them with an audit, even in terms of data, to show them how data is used and things like that. So we follow all these processes in this principle called privacy by design. And this picture is actually not taken from Relex, it's taken from outside the world, just to clarify. It's developed by one of my previous colleagues at Silo AI, Erlin. You can check out the blog to know more about this. And then real-time monitoring. So we monitor all the logs that are coming out of the production system in terms of the model input, the model output, telemetry data, system logs, if we have any potential crashes, if we have any exceptions, and these kind of things are monitored. And there are some practices that I can recommend you looking into. So there are these tools like SonarQube and Veracode. These can help developers to check for vulnerabilities in the code, because sometimes we might have certain variables in the code or some sub-secrets or certain things that are not meant to be in the code, which can be risky to have. So these kind of tools firstly help you analyze the quality of your code and then provide any security vulnerabilities. And also when we deal with the containers, containers can quickly get outdated, and there are different patches coming up to keep them secure. So these tools also help in keeping the containers security check in real time in a way, and then giving us health report of those deployments. And we of course focus on end-to-end auditing. We are getting there to a place where we can completely automate the auditing process. Auditing is not easy. It involves a lot of human labor, but that's where maybe one day machine learning can help us to fetch the right sources and to have this trackable pathway as to how the data was used. But that's a bigger vision. Yeah, I'll take a pause here and take a few questions.
Are you utilizing homomorphic encryption in the production projects?
We are trying to, not for every use case, but that is the goal.
What kind of tools are you using for that?
I think I can't go much into details on that. Yeah.
Random question. Isn't the decrypt word the example supposed to be encrypt?
Oh, yeah.
Okay.
That's
I just want to make sure I'm not confused. So like that's the idea basically. The operation is always happening behind the encryption, so you never actually see the encrypted data.
Yeah. The principle behind this is simple. Like if we not even look at the equation, it's having this combination of public and private keys. So only with your private key you are able to decrypt the data and use it. People who don't have the private key are not able to use it. Basically that's the principle. and we can use techniques to create ciphertext. There are good algorithms like SHA-256, which are common practices, and other techniques too.
Actually, about that, like, because I know that, let's say you're doing like image processing, there's a lot of like linear operations happening. Like, do these encryptions techniques also adapt well to like more complex linear algebra operations, or like when you do like these activation functions in the middle, does this behave well as well?
The encryption doesn't go to that level as to we encrypt and decrypt the data packets sent to the system. So let's say I'm the ML model and you're sending me data. So you encrypt the data with your private key and then send it to me. Then I have my private key. Then we establish this decryption, and then internally within the system we send this data to the model, which then doesn't deal with all of this.
Because I've actually heard that like literally like the whole model is running on the assumption that data comes in encrypted and the model never decrypts anything. So like an example would be like, let's say the encryption function is the exponential function, right? So instead of adding the inputs, you multiply the encrypted inputs.
That's one way of doing it as well.
Yeah.
But I have not usually gone that way.
Okay.
To keep it simple because of
it's very complicated.
Yeah.
I mean, it's like the way I was imagining it, so that's why I was asking.
Yeah.
How do you train the model with encrypted data?
We don't train with encrypted data.
You don't train, it's the same way, like
Yeah.
you send it to the...
That was basically my
It's
question.
only for
Yeah, okay.
it's only for transporting the data from one place to another. Because that's where it's possible for outside players to cache the data. And if you have like good security where you don't have backdoors, then you can do whatever you want to do inside the system. That's at least our belief. It works so far.
Yeah, I guess it would be if you would be training with your data on some other person's system. Keep it completely encrypted.
It can be use case to use case like that. But then yeah, we are quite strict about how we use the data because different customers can't mix and match. We have to be transparent with our customers, and then we have to make sure that it's securely used.
The access part is not easy for even internal people.
Yeah, but maybe the question is about the personally identifiable data, not about like particularly the encryption. You can just obfuscate data, which is like a categorical data to the model. That wouldn't change the model performance at all because it's just categorical. You just encrypt the names, whatever applicable, then model to model is just like a key kind of. So that we do basically, if because we have like personal identifiable data for each individual that we are not allowed to access. So those data is actually always obfuscated in like a direct accessible manner, and it goes that way into the training. But it doesn't matter because we always convert that data into that obfuscated format before doing inference as well.
Yeah, that's one way to go about it, to handle personally identifiable data. We do that as well. So for training purposes, it's anonymized, and even inputs, we try to anonymize as much as possible.
So you use differential privacy, that's all?
I think so in some ways. Yeah. But let's continue, we'll take more questions at the end. We go to the governance part. So if we saw at the beginning the MLOps workflow, which have the build, deploy and monitor blocks. So in the monitor block, we go a bit more detail now. And in the monitor block, we're basically trying to have explainable monitoring method to understand the inputs and outputs of the data. So here in the monitoring block, we check for the data integrity. So I think data drift was mentioned. So data in the real world is changing dynamically, right? So let's take the example of COVID. So when many people were hit by COVID. I think a lot of jobs were lost and the whole supply chain operations were shifted in the world. There was a lot of change happening. So we can see that the nature of the data was changing in many cases. So in order to cope with that, we need to understand the data drift in a way. How is it changing so that we can keep our models up to date with the latest trends. And then model drift is, in simple terms, looking at how accurate or how well the model is performing to the input data. And then application performance, of course, important. When we deploy model in an application, we need to be able to see if the application is not crashing or if we foresee any errors. So we also monitor the application performance, and then analyzing the data is important. So data can be analyzed in different ways. So there are different techniques. Data slicing is one of them. So taking the whole data and then slicing it into different chunks. It can be in different groups based on certain parameters, but testing the model performance in different slices can give a different perspective than rather putting all the data together and calculating, for example, the F score or whatever metric that we set. So data slicing is an important thing to check the model performance. Then detecting bias and threats in a sense of security threats, can be adversarial attacks. And also important to understand if there is a bias in the model. So we can apply such techniques as well. And then important to get local and global explanation. So what this means is we have all the inputs and outputs, let's say for 1 month, for a certain model. We should be able to look at each single prediction and understand why the model is giving such a decision. For example, if it's a decision tree, we can drill down and see. So better if the model is not a black box. Then we can understand to granular levels as to what the model is doing, and then we should be able to see on different data slices or also on the whole data set that was generated for the 1 month, for example. So that's global explanation. So looking at it granularly and looking at it on a bigger perspective. So it's basically like zooming into a picture in simple terms. And then we're coming to the governance part. And the idea of governing the system is to first enable automation. The more automation it is, it's better in many cases. In some cases it's not. So it's case by case. But then we also try to achieve optimization in terms of resources, in terms of people, because MLOps, again, it's a lot about people and optimizing processes as well. So also the goal is to enable transparency within the organization. So governance covers all these parts. Let's look at first what this first thing is. So if you see in the governance block first, we can see 3 aspects: alerts and actions. Secondly, model quality assurance and control. Third is model auditing and reports. So when it comes to alerts and actions, a lot of text here. Try to keep it simple. But there are different type of alerts that we can have. So those alerts can be like based on the availability of the model. So we can check that if the model is not available for a certain timeline, we can generate an alert. Then we can have alerts when requests are failed to the model. We can have alerts when the server response time is longer than usual. We can have alerts when there are server exceptions in the application. We can have alerts when we notice some different trends in terms of data drift. We can have trends when the model is not performing well based on the model drift. We can have alerts based on errors and exceptions in general at any point. So what do we do when we have alerts? We try to take certain actions, and these actions can be automated or it can be human assisted. So certain actions that can automate the system are model redeployment. So taking the same model, redeploying it, that will start up the whole application as well. So you'll have a fresh deployment. Or model retraining. It can be on the latest data set or it can be taking the same data set, depending on what you want to automate. And then it can be deployment server restart. So you have your application deployed on a certain server or deployment target. So restarting that compute, it frees up the memory and gets it as in a default state. That can help in some cases. Or in some cases, just retrying the requests, because sometimes requests can fail because of multiple factors. So trying that or automating that can help as well before shutting down the system. And then sometimes the memory is not optimized in the system, so the cache can get full. Clearing that out periodically or automating that step can also help to govern better. So these are some things that we can do as actions. And when we come to model quality and assurance, it is important to ensure that the quality of the model is up to date without going into text, because a lot of you are reading text, but maybe I'll simplify this point. We try to keep the quality at a certain level. Whenever the model is deployed or even a training phase, we should have certain thresholds in terms of model accuracies, in terms of data drifts, in terms of server performance. So we try to assure that, and we control the system based on that. And it's important also to have end-to-end lineage when it comes to all of this. So whenever, if you want to look back in the history, we should be able to look back. But we come to the end-to-end auditing part. This is also a very important aspect within companies. We are becoming more and more data-driven and data-aware society. So it's important to take this angle into control. So model auditing and reports contains these three important angles. One is to audit the data. Auditing the model is important as well, and auditing project and governance in general. So if you audit these three aspects, and for a company like Relex, for example, we are building up MLOps practices. It's a journey. It just doesn't happen overnight. But we are heading to this place where we are trying to automate the auditing process as well. Let's say some customer asks what happened with our data. We should be able to show them transparently, right? So it's important to audit everything from data angle. So what is happening to data? Where is it going? How is it being used? And what exactly is it resulting in? So these kind of questions can be answered. And these audits can be quarterly, these audits can be yearly, depends on your own use case and the process you want to follow. And then model auditing is important to keep track of the model performance of all the models you've deployed, all the models you've trained, so to have a proper track record and to have a lineage to the data and code that you used as well. So that helps to understand what is happening with your data and model. And then again, MLOps is not just about data and model and code. It's also a lot about people and processes. So also important to audit the process and the way you govern it. So having these three perspectives can give you the ground truth and transparency in a lot of cases. So that's how auditing can help. So when we do data auditing, we look at usually the kind of drifts within the data, how patterns are changing. And then when we audit model, we can look at the fairness and the performance of the model. And the third point, we can always audit the process and see if we can improve anything. So having this kind of auditing process, it's not maybe part of machine learning in general, but it's part of the whole organizational functioning process. So it's good practice to audit all of these things. Yeah, before I end my presentation, I wanted to leave you with some food for thought, and just wanted to have this question: what is the next big thing in MLOps? What do you think it is?
You mentioned something that was a bit meta, which was that you use machine learning to audit your machine learning process. Amazing. So for me, like if you actually get there and this is gonna, I mean, assuming that at some point you're going to stop this meta thing, and then like okay, now there's a human being who just like okay, this stuff.
Yeah.
But that like if it becomes big enough that maybe like your auditing machine learning process is auditing like a lot of things, then it becomes like its own product, let's say. That already sounds to me like pretty next level.
Oh, amazing. Yeah, so automating this auditing process using machine learning is what Patrick says can be.
I would say it's as simple as like having worked on an ML platform for the past 6 years. first the thing was that we had to come up with a term so we can say MLOps and people understand what we're talking about. Now people have understood that they need it. So we are kind of at the stage where laptops and Jupyter notebook files on your desktop don't do it anymore. So the next big thing is going to be everyone actually using a solution right out of the gates.
Oh, that's a good thought. What's your name and which company are you from?
So I'm also from Malohai. I think we've talked before.
We've talked before. These guys are doing great work in MLOps. Check it out, Malohai.
But what do you guys think about AutoML, which basically renders MLOps irrelevant, mostly?
Well, you can tell that to our customers who are doing like training 100,000 models in parallel, and each training takes like, I don't know, 20 hours. And they have to limit the amount of parameters they are searching there manually. So doing it automatically is still kind of too expensive.
It is, and also AutoML has a different niche. It doesn't relate to MLOps much. MLOps is a process in general, so let's go there. So if you look at this process, AutoML comes into play here. AutoML, you're using multiple algorithms in a way to fit the best algorithm to your data. That's where it comes in. MLOps is the process itself. But talking about automation, we're coming there. I think that's a good thought. And let's get back to the question now. The next big thing in MLOps.
AI Act.
AI Act.
Yeah, the regulatory framework.
It's an important area, yeah. Without that, we're doomed as humanity.
Is there a question about the data platform again? Is there kind of a standardized or open source solution? Or why did you actually end up having your own proprietary solution on Relex?
Because data, you can't really keep it open, and we have these GDPR and other protocols, so we had to, our data was starting to be in silos, and we saw value in centralizing it for fueling such operations like MLOps and fastening model deployments, because in the industry we are at a shift where we are going to take data-driven operations. So we went with that approach.
Yes, so it seems that there are of course cloud solutions by these big companies, but is there kind of an open source or standardized solution yet?
There are. Apache has quite some tools, and there are quite some companies actually building open source tools as well. But at the end, maybe not one tool can serve everything. For a company like Relex or big companies, it's usually a culmination of different tools and technologies that makes up data platform.
Yeah, I think the answer that you're looking for, I guess, is that like outsourcing the management of your data is basically saying like, look, this is the thing that I call my oil. You're the one that's going to do all the work with it. Right? It feels like you're not considering it as a main asset in your business. And so if this is something that's really important for your business, you want it to be managed like properly, securely, but also like optimally, so that you don't actually incur useless costs. And like back in the days, like let's say 20 years ago, if you had a server, it was like your baby, right? Like I'm a web business, I have my own server, I need to manage it. But now everybody has computers all over the place, so having a computer is not part of your business anymore. But I think we're still at a stage where managing your data is not something that you just securely and carelessly outsource.
Yeah. Again, we come to that Acts point. AI Act, we might not have it, but we certainly have Data Act, GDPR. You can't outsource the responsibility to someone, and there's no plug and play for this easily available in the market at the moment. But to conclude, I'll leave you to think about something, and maybe this is something for you to learn, and this can be a big thing in next 1-2 years. That's my prediction, and a lot of companies would need this, and that's called AI Ops. It's funny, isn't it? AI Ops is different from MLOps. MLOps is combining machine learning and DevOps, so that's the way we do it. But AI Ops is applying machine learning on your DevOps practices. So what this means, let me give you certain examples. So let's say you have a lot of server logs that contain your model input, output, and your system logs where you have certain errors in the system. So how about training a model that can detect errors using predictive algorithms and foresee if an error is going to happen in 1 hour or something like that? And then these kind of systems make AIOps, enabling predictive capabilities to your DevOps practices. So that's just one example. Company to company, there can be many examples, but AIOps also first predicts the problems and then automates the error resolution process. So before that system crashes or before an adversarial attack happens, for example, then it is able to automate certain actions and perform certain scripts, for example, to do model retraining, model deployment, or shutting down certain processes. So these kind of things in AIOps, however funny it might look like, but this can be a big thing. And
actually, I heard of a pretty interesting product in that space. Basically, let's say you have Kubernetes cluster, and you're reserving your own nodes with Terraform or something like that. I mean, your thing is running, it's fine. But then you request the resources like nodes on demand, and then you reserve them for yourself, and you manage them yourself with your cluster, and you decide how many nodes you want and that kind of stuff. But actually, let's say some of those nodes are running services that are not running all the time, or maybe that they only run based on load. If they're Python APIs, maybe during the night you need less than during the day. And there's a product called Spot by a company called NetApp. And basically what it does is that it decides based on usage and the data coming in and out of the servers, which nodes to buy, how expensive they have to be, how much resources they need, and regulates the load without any human intervention. So it's basically resource management done by AI, right? And they actually managed to save costs up to 60% of a cluster.
For example, this resource management, that can be one use case. So it's a chunk of use cases that can make up AIOps, and if you get into this, you'll be ahead of the game. And yeah, with this thought, I'll leave you to ponder, and it's been a pleasure to present to you. And we can keep in touch on LinkedIn. Thank you.
Why didn't you apply to you?
Actually, I applied. I don't reject it.
Who rejected? Who was the hiring manager?
There was some lady. But you left.
Hey, let's start Dennis' presentation. Please.
Right. So, based on the 8th, you know that correctly today. So anyway, I'm Dennis and I am a researcher at the University of Helsinki. Data science background, and my research is in MLOps, which is the topic of today, but I particularly study deployment of machine learning systems. That's my focus area. And I think all the talks that we've had today have been quite excellent in trying to set the stage for my presentation today. All of them. I think what I bring now is evidence from the industry, because this study is based on interviews with practitioners from different companies, as I will show. So it's an empirical study. So what we will see here is basically hardcore implementations of the tools that are used compared to all the things that have been spoken by Patrick and also Emmanuel. So what Emmanuel has spoken about, what Patrick has spoken about, I'm basically be trying to qualify that based on how I have seen industry experts actually do things. And feel free to ask questions as we go along. So the talk is based on a paper that we published in IEEE, and that's the ID of the paper. So if you go in there, you should be able to access it. I'll just gloss through it. Or you can, and it's open access, so it's freely available to you if you want to read that. So the setting is that it's all based on Finnish companies. The companies are growth startups and very large companies also in the study. $49 billion in revenue, 100,000 euros in revenues for the small companies. So quite a wide range of companies covered here. Maybe I should have already gone to the companies. The companies that I'm talking about present a lot of things in terms of where they operate. If you look at the domain in terms of the business sectors they intend to operate on, they vary quite a lot, from finance to pharmaceutical companies, companies that are dedicated in making IoT solutions, healthcare sector, and so on. Here we try to show generally where does the data come from for the machine learning systems that are built. The data is sourced from internal systems, as we heard in the case of Relex. In some cases, data is coming from real sensors seated in buildings or in cars or things like that. But a large share of them are basically built from internal systems. If you look at sort of the systems that are represented here, I will basically try to highlight 50% of these are neural network based, and then you have another 50% that are not neural network, so they're based on basically classic machine learning these are the case companies, and why do we study these things, or why did we see it necessary to study this? I'll go back up. For those who have been in academia or have taken courses, you probably know this paper by Scarlett. This guy is quite renowned guy from Google. And what the paper presents is that he talks about hidden technical debt in machine learning. So he presents the case that machine learning tends to be a very small part of what you do in practice. But a large part of what you end up doing is figuring out how to run that system and how to maintain that system. So our study basically tries to, or try to talk to practitioners to sort of qualify this notion. And we did get a good view of that. And the other thing we tried to bring to the table from an academic point of view is that most of the research papers that you will find, I already mentioned Google, tend to come from large corporations. So we don't have a lot of evidence of what non-large companies do in practice. And so that's what we bring with the study in this setting. The conversations that we had, or how we extracted the data from experts or practitioners, is we looked through this framework. It's been presented in various forms by Patrick and Emmanuel. You're looking at how people run their data pipelines, or how they tend to manage data, specifically for machine learning workflows. Of course, you have the model training, and then you have the deployment and monitoring aspect. And then we also looked at techniques or how practitioners actually manage the entire pipeline of the entire workflow. So this was the framework of discussion, and now what I will do is present the sort of the results in terms of practices and the tooling that is used in all these phases of this process. So we begin with this data management patterns. Of course, we didn't drill so deep as maybe the framework presented here in terms of data pipelines and how they are actually working through this. But we tried to get an overview of how do these guys actually manage data that is particularly managed by machine learning workflows. And we structured this in terms of we discussed about storage and version controlling of the data. We noticed there's also a sense of abstracting the data when you're doing machine learning, and we'll discuss why. There's documentation of the data, and then there is data quality issues that crop up. So storage of the data is quite obvious. Of course, every company has the way it stores data. Either you're buying it from third parties or you have your own, let's say, storage solutions. But from a machine learning point of view, what came up is that it's very important to think, especially when you're dealing with neural networks, where your data actually sits. The reason for that is that it may constitute a large part of your training part. So if you're fetching data from, let's say, network, and the machine learning training part is of course completely, then you add an I/O aspect that tends to consume a large part of your compute time. So it became clear that some of the times you need to figure out a much more efficient solution to how to store the data in close proximity to the compute resources, and not just streaming it from S3 buckets, for example. The other thing is that the coupling of data from model images. In some cases, we did see that companies have an image that contains the data and the model itself, but the result of that is that you end up with build times that are pretty slow because of having data within the same image as the model itself. The other thing here is about version control data. I saw a graph here that showed version control running through the entire workflow. It's not a very trivial thing to do in certain data sets. When you have certain tabular data, for example, text data, it's quite easy to do, but if you have video images, very large, you have to think of creative ways how to sort of version control this data. And most of the time, you have to come up with metadata of the data and version control that metadata, because it becomes almost not so obvious how to version control speech and things like that. The data abstraction part, it speaks especially for large companies, that data sits in various silos, and the data scientist has to work with all these different data sets. So what we saw is some efforts to try to abstract these data sets so that you're not dealing with CSVs from this side, you're not dealing with Excel files from another team, and so on and so forth. So what the platform team tends to do is come up with this standardized interface, for example, using XDF or Apache package, so that the data scientist can consume an abstracted data set and can emit the same abstracted data set, and another team can actually carry out the deployment of the model. So it facilitates a lot of a fair share of portability of your system, especially if you want to test new frameworks, if you want to move the data to a different, not the data, but the model into a different cluster. So if you have sort of this abstracted data set and data formats, that tends to be a bit easier to achieve. Documentation of data is something else that seems to be an issue in large companies, in the sense that, again, if you have data seated in different parts of the organization, let's say the organization has an insurance arm, it has a consumer finance arm, the data scientist usually does not know where to get the data for a static model that they want to build. So for that reason, as a good practice, you will see that some companies that have this figured out, they have sort of data catalogs which then can facilitate discoverability of data and allow the data scientists to easily figure out what sort of features can be extracted from which part of the organization. Yeah, like that. Data quality, this is an always open problem, irrespective of which type of machine learning you're doing. But some efforts to actually try to improve on it. We saw that in some cases companies have a dedicated team that takes care of the quality of the data, and that ensures also that the schema, the data is actually validated at various levels, the schema and the data itself. And this is done by people who are actually in charge of data quality aspects in a dedicated fashion. And then it's important also to define what data quality means in your domain. It was clear that it's not the same, obviously, if you're dealing with video data, if you're dealing with speech data, if you're dealing with data collected from web crawlers and so on, it means totally different things. And so for this reason, it was evident that there needs to be a clear definition of what good quality data means, that even if you buy from that party providers, then you actually can stipulate what you're looking for in terms of quality metrics of the data. Training model evaluation. The type of things that we noticed is that transfer learning was a big thing that addresses neural networks. I've seen here the presentation by Emmanuel saying that it's one of the attack points that can happen. Actually, that never came up from all the interviews that we did. But I did notice that most companies, not most, but a fair share of them were using public models to actually motivate their own models to address the old stuff. And then a few of them were using private models as baselines. And those that use private models, or let's say one reason why transfer learning was used a lot was a cost-saving measure. So if you have a large model that is trained for 2 weeks, for example, it was not necessary to be doing that on a regular basis. So what guys did is they have different cycles of training, 2 weeks, and let's say a much more shorter frequency of training. And that's the application of transfer learning. The other application is to avoid a cold start. But the choice of public and private is all dependent on the availability of models that are actually much more available to you. Or I didn't hear any company that spoke about security, but that was a really nice speak. Explainability of models is something that came up, and this was spoken especially from regulated companies' point of view. There are some companies that it's not enough to have a very good model with very good accuracy if you cannot explain how it achieved that. So for that reason, some companies actually forego very good models and opt to take heuristics because if the regulator comes along and asks how does this solution come about, they can actually explain it a bit more in a straightforward way. So in this case, they use these models more as a benchmark to see how much off they are from like the best possible model they could achieve. But for reasons of operation, for operating purposes, they use things like heuristics that are much more easy to explain. And then you have evaluation of models. So how do you tell that your model generalizes very well? We did see one company that had a very good solution to this. And what they've done is that they've stored data in different qualities, different levels of qualities. In the sense that the data is stratified that this data is really clean and can give you a perfect model. This data is half clean, this data is like not so clean. And so when they train the models, they are able to see how it performs across these three data sets, for example. And what happens is that, of course, if your model scores very well on data that's super clean and scores very badly on data that's quarter clean, of course, you need to do some adjustments to the table. But at least it quickly tells you how well the model can generalize, even studying maybe not so clean data if it's open to the public. Frameworks, network architectures, and things like that. The question here was, so how do you choose your framework? Let's say you want to build a speech model. You have, of course, you can choose Python, you can use TensorFlow, you can use the Calvi framework. And we did find some organizations that are actually in the same space in terms of models that they're trying to build, but use different models. So that might be the question, why different models, why different frameworks? So, and most of the time is, if the CTO is very well versed with the framework, they will choose the framework that they feel gives the most flexibility. In terms of, if I want to tweak certain parameters, certain hyperparameters, very low level stuff about the model, they know where to go when they need to tweak that. Others will choose it based on maybe the underlying computational engine. For example, if it's NKL or it was implemented in C++ compared to another one implemented in another Fortran. So in some cases, the sort of technical team is very opinionated on why a certain library makes more sense than another, especially for performance reasons. And of course, something else to consider is the architecture of the neural network. For example, if you think about the REST network, there are so many variants of it that you could use. So in that case, you ask them, why did you choose this one and not the other one? We'll see that later. Performance is a big issue when it comes to that. One neural network might perform much better than the other one because of the resolution of the images it consumes, and maybe it's tweaked, the layers have been tweaked in a different form, so that informs this choice of the neural network. And then there was this issue of experiments. How do companies actually track experiments? It was mentioned already by somebody that notebooks are not useful at some point. You have so many experiments you need to run. So how do you manage it? As you will see, there are very many different ways to do this. There is a tool called MLOps. At the time when we did the study, not so many companies actually use this. I wouldn't say it's not structured. They have a structured way to manage the experiment, but in different ways. You would imagine that there is a nice tool to do that, but actually not everybody uses the tools that you actually imagine they would use. Yep. And deployment and monitoring, this is a topic that I closely follow. When you talk to practitioners, what are the main issues that you try to capture when you deploy? You model and monitor it, and when you consider monitoring. So latency is a big thing, and the after fact that we had with a lot of developers is you need to start considering it much more earlier than you do in practice. So when you're choosing your architecture, when you're choosing sort of the stack, you need to already start to consider how to get very good latency. Improving it later on is a much difficult task. So for that reason, you need to bring it early on in the game. And it means, for example, choosing the protocols that you're using to start. Are you going to use gRPC? Is REST sufficient? Things like that have to be decided pretty much early on. Yeah, I think I've already covered that. Monitoring for model stillness. This is what was called drift. Of course, it can happen in different ways. And this is very complicated to do in production, particularly concept drift. We did see some cases or demonstrations where there is no good way to do it, especially if you cannot store the data that you're getting for inference. It's not that trivial to actually determine if your model is drifting. But from a research point of view, the topic on calibration, model calibration, comes to address sort of this issue in production. And then infrastructure utilization. From a software perspective, we normally, when we think about performance and moving and scaling, it's usually quite straightforward to scale horizontally most of the time, provide more resources, and then you're good to go. With machine learning, it's not necessarily the case. For example, speech recognition systems. If you're supporting a real-time speech recognition system, and you get a payload longer than you would expect, it tends to hit a node, and it's not obvious that scaling horizontally, providing a new node, actually would solve that problem. I don't know if I'm clear with that, but the idea is that in some settings in machine learning, for example, object detection, of course, you can send an image. If you get more images, you can scale, and the new images can go to new nodes. But in systems like real-time speech recognition, it's not that obvious that horizontal scaling would actually solve the problem. And so, still an open thought and area of research how to actually scale in some of these machine learning use cases. And if we think about the entire pipeline now you've done your data management, you've deployed, and now you need to think about repeatability of this whole process. And in some cases, some companies have very, very elaborate ways how to do that. In other cases, it's a very manual process, end-to-end, just tweaking everything every other day. But the lessons learned here is that version control, as we saw in one of the previous slides, is something that should cut through all the stages of this process. So in an ideal setting, you want to start with infrastructure as code, and end up with deployable containers. So everything can be replicated, everything can be traced back, and things of that sort. The other thing that we noticed is that encapsulation of every stage of this workflow into independent containers wherever possible. So that will facilitate, of course, automation. And if you think about things that are highly distributed, that will increase the efficiency in terms of collaboration among the team. So, but building scalable pipelines in reality is not trivial either in machine learning settings. But there's a lot of effort how to do that. Of course, we've seen tools like Celebrate, which can be used in this case. But oftentimes this means you must adopt some form of container orchestration platform. Yep.
Did someone in Finland actually use Celebrate?
Yep.
Okay, cool.
Yep. And Sweden as well. So, yeah, so scalable pipelines. Scalable pipelines are, in a basic sense, it means, of course, if you have Kubernetes or you have Celebrate, something that allows you to actually orchestrate and manage this entire pipeline, if it's already containerized, then you're on to something that is scalable. And then, of course, if you're thinking about the entire pipeline, you must be able to test all the container images for integration, as we'll show here in one of the pyramid features. And one challenge is how to keep all these tooling up to date. There are so many tools that you need to manage. How do you keep them all up to date and keep your stack up to relevant?
Sorry.
Yeah.
Can you go back 2 slides from there?
2?
Yeah.
This one?
This one? Yes, this one.
Yeah.
Because you mentioned that, like, in terms of using infrastructure, like scaling horizontally doesn't solve the problem. Do you mean like the case where the input can come as a string in real time and the length of the string is unpredictable, or do you also mean like, let's say it's about applying like variable length of audios but reasonably bounded, like let's say within 5 minutes, and it's just a matter of like distributing that would not be solved?
The case that was explained was the first one.
Okay.
So you get a hit on the endpoint, you have no idea when it's going to end, and for some reason it just keeps going. So then you have sort of this imbalance in your nodes, and it doesn't make sense to actually just provision a new one. So,
have there been like strategies considered of like chopping off the stream in some sense? Just kind of like say, okay, you can only stay on one node for like a minute, and then after that the next like minute minus 5 seconds goes to the next node or something to be able to like, do you know like some things that have been tried just as a curiosity, or?
No, but the use case here was maybe causing the problem because it was a UI tool.
Oh,
so,
okay.
So in that sense, the feedback is quite. There's sort of some real timeness in sort of the feedback that the user needs.
So like switching nodes.
It's just not. Yeah.
Okay, interesting.
How about sometimes we have data which is good enough to do the real-time processing, and sometimes we need to schedule because it cannot be give you the answer in real time. So did you see any example in the infrastructure utilizing that they were handling both cases at the same time?
If I understood your question, so the capabilities to handle real-time and batch processing.
Yeah, batch processing, exactly.
No, majority of the time there was usually one use case. Batch or online.
Or online,
not together. Not together. Yeah, I think all of them are. Actually, when we set up the study, to scope sort of the discussion, the team had to bring one use case, even if they had multiple models. We had to confine them to sort of one use case. Yeah, so we were just about to now look at the tools. Now, I'll just show you, so it's easier to just look at the distribution. If you have time, you can look at the paper. But here what we try to do is to go for sort of what platforms we are using in terms of storage. As you can see here, AWS is quite popular. Followed by Azure and Google Cloud, and then we had one on-prem sort of setup. This is like a public, not a public company, but public service. So they're not allowed to be on public cloud system, so we have on-prem solution. And when you have such setups, there's a lot of information that is required to actually get your system up and running. What I want to maybe highlight here is when you look at the frameworks, in most organizations, you're using multiple frameworks to solve different things. I think that's how I put it. I mean, you rarely have companies just relying on one single framework. Use multiple frameworks for whatever achieves the solution that you're trying to shoot for. You're able to deploy the best framework for the task that you think can solve the best.
Could you investigate on the reasons like why different companies would use multiple frameworks? Because I can imagine a very large company might just because of the diversity of employees.
That's the main reason.
But like in a small company, you have a hard time matching it.
So the main reason, at least across all sizes, was that nobody is compelled to use a statistical framework. So a data scientist should use the tools they feel that they are capable of using. For example, I think it was this case where I believe it's this one. Yeah, I think it's this one. Yeah, so this one, this is a chatbot system. So somebody could build a proof of concept with a TensorFlow framework, but you also still ended up the production level using that. Some of these things dictated sort of the frameworks that we use. No big surprises when you think about version controlling, but the interesting thing is that at least when we did this, this sort of started to come up as a potential solution. There was this sort of version control picture we had earlier, but Git is not suitable for everything in the entire workflow of machine learning system. Let's say machine learning workflows. It doesn't solve all problems in all cases, especially for data version control, and that's why this sort of shows up. This is sort of a dedicated tool that can actually version control the data and the models better, in a better way than Git would be able to do that.
When you say Git, you mean that Git self-hosted?
Both cases. Cloud, I mean, what do you mean?
No, because maybe I'm just naive, but I've seen mostly Git being used like from GitLab, GitHub, Bitbucket. It's like basically a provider.
Yeah.
I'm trying to picture what do you mean by
Yeah. So here we just asked them what sort of Git solution maybe do you use? So this is like classic Git. And then somebody will say, no, we use GitLab.
Okay.
And they have these opinions on it.
So nobody GitHub.
I would imagine some when they say GitHub.
That's where I was going with this.
Yeah, so I just summarized Git related sort of with GitHub Git, I would assume that it's sort of GitHub solution. So,
It sort of makes sense. I understand what you're saying.
GitLab, Bitbucket, these are also Git. GitLab, Bitbucket, these are also in a way using Git, right?
Yeah. But the solution
That's why I was asking.
That's what I was asking. But my point is that, if you ask them, we didn't probe them why, but some are just opinionated that they probably like some aspects of GitLab that they wouldn't actually find in GitHub or something like that. For some reasons, it's legacy. They started that way. That's the culture.
Okay.
No particular. We didn't really probe it further why this is the case. But at least we try to understand any sort of structured solution in terms of version control. And at least in one case, this company, you can see that it has data and then it has a dedicated tool to actually cover data as well.
So the sample size of the companies is 10?
16.
16?
Yeah. So some that have not answered anything are not sort of in the distribution.
Are these big companies? What is the size?
Yeah, not all. So there's a spectrum of growth startups, but large of them are mature companies. Yeah, I'd say 80% very mature companies. And actually also bears on the fact that the choice of tools is not, it's not associated with resources. It's probably a function of just what the developers are used to and what actually makes sense for their setup.
Sorry, was the question here about data version control or just version control, like code version control in general?
We probe for both. Did you ask if data or?
Yeah, what are you asking here, like, what do you use for data version control?
Yeah.
And then they're answering GitHub, for example, and I guess they mean like large file storage.
We probed for what do you use at all the sort of the stages of the workflow. And when they say that maybe they still use GitHub, then usually they're saying that they're collecting metadata and not versioning the data itself.
Okay.
Yeah. So then they're version controlling that file as a config file.
Okay.
This was also interesting when we tried to discuss about container orchestration. Of course, Kubernetes is quite popular, but then you still find bespoke solutions on how people decide to orchestrate their sort of containers. And this was because this is the same setup that is not allowed to be in public cloud, so they must be sort of are using OpenShift in their on-prem. But then you still have this sort of setups where they're using AWS Lambda or this Elastic container. In most cases, I think it was mentioned by Patrick, if they're already in a certain environment, there is no need to go looking for any other solutions. So they just use what the cloud provider has provided. In most cases, this is the reason. Machine learning training workflows. So this is I think what we try to capture here is the concept of scheduling your machine learning, but ML training part of the workflow. So interestingly, most of the companies have some custom solution. We do have dedicated tools that would be really good for this. For example, Apache Airflow, Argo, but you still find most of the teams actually have written their own solutions to orchestrate and regularly retrain the model. Or sometimes it's just basically manual. It's a script that's always run manually, retrieve a new model, you have new data, and things like that. Not so many of them have automated solutions to manage their training workflows. Experiment tracking, which I mentioned earlier. A lot of different solutions we saw. Somebody's basically collecting metadata, just storing that in some cloud solution. A few of them were already using MLflow, but you see a lot of variance in sort of what kind of solutions people are using.
I feel like these 16 companies were, the problem they were solving, how complex the problem was, as compared to from one to another.
I'd say, I already said 50% of them were neural networks, already, and quite complex business problems, I think. Complex meaning extracting data, for example, from PDFs. Yeah. So you have OCR models there, you have computer vision models in there, speech recognition models were quite complex in the sense that they were being used in healthcare, if I try to give some context without saying the companies. So they were quite, I'd say, fairly complex problems they were solving. I don't think there's one that had a very basic problem. Yeah. I mean, it's subjective here, what maybe you mean by complex, but I think they are fairly complex problems. Trading, I mean, getting new prices from the market and things like that. So, yeah, I didn't mention the business cases because, of course, we're in Finland, we'll probably figure them all out. But, yeah. But it's fair to say that, yeah, very good, decent problems to solve with machine learning.
None is the favorite tracking solution.
Yeah, as it seems. But all are equally confident of their solution. Yeah, repositories, same thing here. Very different solutions. As you can see, it's quite popular. Just train your model, put it in an S3 bucket. Downstream will use it the way they want to use it. But in some cases, you're as interesting as Postgres.
But, sorry.
Yep.
I'm just interrupting here.
Yeah.
But the data platform actually, like, it's not really another thing. Did you find out that someone is using a data platform to take the data there and,
Yeah, somebody was using exactly Snowflake as their main data platform, but mostly to query data for machine learning training. And once they trained the models, they were storing the results in batch back to Snowflake, so that other parts of the organization could actually use the data.
I didn't see it there or anything like that.
Yeah, but the model is not stored in.
Okay, model is not stored.
Yeah, so this is purely what do they do with the model once they train. Deployment and monitoring. I think here there's not much to say, but what I'd like to highlight is something as mundane as monitoring. You still see people they tend to just collect logs and store the logs somewhere. Instead of, say, having elaborate Prometheus Grafana setups, people are just basically collecting logs. I guess it provides more transparency to later on if you need to follow up on something. But the common understanding is that Prometheus Grafana is not maybe the solution for everybody. And I think it's still in machine learning perspective, it's still a very open area to figure out what the best way to actually monitor machine learning model. It's not enough to monitor the endpoints, but there's much more going on for an ML endpoint than just checking the traffic and the hits. So probably it's the reason where people are just collecting logs and storing them in another solution.
Did you ask about why? Because I'm curious if it's related to the data format or the kind of predictions that they have, for instance. Because I'm guessing, like, if you're in Prometheus and you're asking Prometheus, like, please log this image output with my GAN generated, it's probably not something out of the box.
Yeah, I think at least the main answer that we would get is that, it's not sufficient for a use case. It's not sufficient for a use case.
Okay.
So, yeah, that's one of the main it just doesn't serve our purpose.
Okay. So I'm guessing like there's a plethora of scripts being written and then it's like the surface.
Yeah, and putting them in Elasticsearch and then they can do whatever they want to do. Yeah. So the main problem, I think, if I would summarize, this is the problem. There's just too much to contend with in terms of tooling. From an architect point of view, you have to make decisions and sound decisions to choose from all the solutions. That if you think about data management, there's just so much you can use out there. But what actually works for you is still something you have to explore. And this is the current state of MLOps right now. And we probably think it's going to consolidate at some point. For example, if you look at the experiment tracking, I cannot now figure it out the way it is. So MLflow should be somewhere here, the experiment tracking. So already this is pulling up as one de facto solution. So sooner or later then we'll probably have something that's much more dominant in each of these segments. And then we'll have sort of so what they have in DevOps now, things are standardized in DevOps. In MLOps, probably things will get standardized once these tools emerge as dominant in their own segments.
And you got the question earlier, like we had a lot of MLOps cases. This is why. Like they call, they say, oh yeah, this is interesting, let's work with you. We are looking for an expert in tool 73. It's hard, you know.
Yeah, that's the reason why Valorant is there in multiple boxes to cover all of it.
And do you think they want multiple of them?
Yeah. I was just wondering if Valorant would.
Yeah, it's in multiple boxes.
Yeah, but you see yourself dominating sort of one space.
This is kind of focusing on the parts, and we are maybe dominating the end-to-end. So it's kind of, we are not trying to dominate, like for example, Seldon is deployment. MLflow is
experiment management.
Yeah, kind of like management and maybe like tracking to some point. PVC is data version control. Valorant is kind of covering all of that from end to end. So kind of Valorant is all about the pipelines, building a pipeline from beginning to end.
And also maybe there's one box missing or it's too tiny. Orchestration.
Yeah.
Maybe that's good. That's what Valorant is good at.
Yeah. That's what many of the others are not doing. They are not doing orchestration.
Yeah, it's a major problem in the industry. It's been overlooked, but it's good.
Yeah, I think MLflow is also moving into pipelines as well.
I'm guessing they're trying to move everywhere because it's basically Databricks building and then also.
Yeah. So yeah, that's the business case for MLOps. Yeah, I think that pretty much summarizes my whole study, and I encourage you to take a look at it. It's an easy read, actually. It's not very technical. It's quite easy read for the weekend. Yeah, so too many tools to deal with. As we've seen, the workflows and pipelines, they vary so much depending on the company, and particularly depending on the way of machine learning that they're working on. And then you have to contend with this issue. If you're a practitioner, do you go for integrated tools? For example, SageMaker, which has everything, or do you compose your own solution? For example, what is done with things like Valify and other solutions. But all in all, of course, you need to consider the flexibility of your own pipeline. And then longevity of the tools, something that needs to be thought about when you're using your pipelines, and how to decouple the small tools within the pipeline so that you can actually replace them much easier when needed. So yeah, I think that's pretty much what I had to share today, unless you have more questions. And happy to connect. Yeah.
Did you agree with the Google study in the end or not? Like, do these Finnish companies follow the same trend?
Yeah, yes, that's some of the subjective things you gain from the interview, that it's much more than creating a model. Yeah, so that part we agree. When it comes to comparing companies that are not large and how things are done, there is a stark world of difference. Very different. So in that part, it's good to read the papers from big companies, but usually the solution will not work in the setting.
I was listening to when you were mentioning about that mostly companies try to go with a simple model or a heuristic model actually to easily explain it to the user that how they have come up with the conclusion. But at the same time, I was reading a white paper which was saying about that while providing humans with interpretable algorithms counterintuitively lead to low decision-making performance. So if your user is you're trying to make a model which is easy to understand, that white paper actually shows that they trust less and they ask more questions about it instead of using it in that process. If you come into this situation where simple models are having struggles to explain to the users, and so when the users are trying to ask more and more questions about it.
Yeah, I'd maybe put it this way. In the setting that we were in, the person who needs to be explained for is a regulator. So you would assume the regulator is sophisticated enough in the field to actually understand what is a sound decision and what's not a sound decision. So in this case, the regulator wants transparency so that the company does not harm citizens and things like that. But it's not something that end users consumer contend with, but it's something that you contend with at the business level in terms of regulatory frameworks that you have to deal with. Healthcare, for example, banks, obviously, big engineering companies, civil engineering companies. So they are the ones who contend with these problems, where the regulator will come and ask, how did you decide to close certain parts of the infrastructure and open the other ones, and you need to be able to explain that. And if it's not clear, bias issues, so these are eliminated by just choosing a very simple model. Yeah.
It's not a user, it's a regulator.
Yeah, it's a regulator, yeah. And the regulator is sophisticated enough to have this discussion. Yeah.
Thank you.
Hey, thank you, Dennis.
Thank you.